All right, scholars. So today we're moving a little bit fast, so make sure you keep up with me. You're going to put your name and date at the top. Go ahead and begin your catalyst, questions 1 through 4, moving with urgency. Go. So question 1 says, which state of matter is the least dense? We know the least dense would be the least tightly packed, and that is going to be our gas here. Which state of matter is the most dense? We know that that means that the molecules are tightly packed together. Almost looks like a little box, box there. Okay, never mind. That's going to be this right here, and that is our solid. Which state of matter has its own shape? Has its own shape. We're going back again to our solid. Which state of matter has no defined volume or shape? Things are just floating all over the place. That is going to be our gas. We can also say that for has its own shape, we can include liquid there because a liquid is going to take the shape of its container. Great job. Actually, you didn't do anything. It was all me. Blast from the past, multicellular or unicellular. Multicellular means something is made of two or more cells. Unicellular means that something is only made of one cell. So for example, humans are multicellular. We're made of like a cajillion, you know what I'm saying? And unicellular is like one bacteria. So you're going to go through this list 1 through 7 and write down the full word, either multicellular if something is like a human made of many cells, or unicellular if something is made of one cell. Put your thumb up in the air right now so I know you are pausing and trying on your own. Okay, go. All right, guys, we're taking our answers right now. We're going to go through this, like I said, rapid fire, rapid quick. So a fish, multicellular, frog, multicellular, bacteria. It can honestly be multicellular or unicellular, depending upon the type of bacteria. For the sake of this conversation, they're going to be unicellular, which means it's just one cell. And we're back with the Mad Scientist Dash, guys. Okay, 1 through 12, you're going to try on your own first. Go ahead and give me a thumbs uppers. Boop. Oh, you can't see it. It's right here. See, thumbs up. So let me know you're trying on your own. Ready, set. All right, here we go. We're going to go over each of them. Directs all cells' activities, contains DNA, is the nucleus. Directions for how to run the cell inside the nucleus is the DNA. Releases the energy stored in food, mitochondria. Storage area for the cell, vacuole. Contains digestive chemicals, lysosome. Semi-permeable membrane that lets only certain things in is the cell membrane. Rigid wall that protects the cell is the cell wall, remember, only found in the plant cell. Traps sunlight for photosynthesis, chloroplast. Variable you change, independent variable you measure, dependent variable, things you keep the same in an experiment is the constant. Group with nothing changed, you can compare it to the groups with the independent variable, is the control group. If you need to go back to get any of these down, go ahead and pause the video and get it right now. Alrighty, guys, today we are focused on experiments. So we know that in an experiment, we have our independent variable, and that is what we change on purpose. And the independent variable is going to affect the dependent variable. So we're going to practice with some sample experiments here. All we want to do is find the variables. So we want to visualize it first, which means if we need to, we may have to draw a little picture of a little flower, you know what I'm saying? A little water on a flower, and then, a little ruler measuring the growth. Let's just see what happens. It says that Georgia performed an experiment to study the effects of sunlight on plant growth. She put one plant by the window and one in a closet. Each plant received a different, it should say, amount of sunlight. After 2 weeks, she measured their heights. So first, we label our boxes. This is going to be our independent variable, what we change on purpose. And this is going to be our dependent variable. This is going to be what we measure. So I want you to let me know right now, what is our independent variable? What are we changing on purpose? The big thing that we want to look at to find our independent variable is the word different. Neil, I want you to close the computer. So what is different in this experiment is that there are different amounts of sunlight for each plant. So the independent variable is the amount of sunlight each plant receives. And then what are we measuring? So based on the different amounts of sunlight, we want to measure the height or growth of the plant. Let's take a look down here. Yesterday in class, we heated up different amounts of water to see if they would affect the boiling point. So we're going to rewrite those same notes. This is our independent variable. It's what we change on purpose. What did we change on purpose here? Again, you want to look for that word different. What is different in this experiment? Oh, I see it. What is different here is the amount of water. So we're going to write that for independent variable. And then we ask ourselves, what is the independent variable affecting, or what are we measuring? Whatever we are measuring, we put here. we are measuring the boiling point. Or you can say the temperature in which the water boiled. All right, once you have that, you're going to go ahead and jot it down. If you need to pause the video to get those down, go ahead and do that. On this page, you're going to try on your own to find the independent variable. Continue to write the notes in each box, and the dependent variable, continue to write the word measure here. Then you're going to name the independent variable. You're going to name the dependent variable. There are 1, 2, 3, 4 examples. Put your thumb up so I know you're working on this silent and solo. Go. All right, so I'm going to go through each experiment right now and identify what the independent and dependent variable are in each experiment. So now we're going to take a look. Number 7 says, Philip conducted an experiment to study the effects of temperature on the rate of the chemical reaction. He measured the time it took for the chemical reaction to occur at 25 degrees Celsius. He repeated the same experiment and the time of the reaction at 5 degrees Celsius. So we need to identify what is he changing on purpose. Right here, we can see he is changing the temperature. That is our independent variable. What is he measuring? He's measuring the rate of the reaction, or how long it takes the reaction to occur. You need to fill that in here. Number 2, he wanted to see how the type of music affected the time it took for mice to run through a maze. He built a maze and sent a mouse through it while playing rap music. And he sent the mouse through a similar maze and played country music and recorded the time it took. What is different here? Whisper it. No, I'm serious. Talking to the computer right now. Excellent. No, you got it wrong. What's different is the type of music he's using. What is he measuring? He's measuring how long it takes each mouse or the mice to go through the maze. You want to fill that in. Number 9, a class is studying the growth of lizards in separate phases. One lizard is named Rachel, the other lizard is named Sky. It says it's lizards different insects. Sky got the mosquitoes and Rachel got the flies. After 1 week, they measured how fat basically Rachel and Sky had gotten. Oh, what are they changing on purpose? They're changing what the lizards, you guessed it, what they eat. Yes, because Sky and Rachel, they were eating flies and mosquitoes. Disgusting, right? I know. Now, what are we measuring? We're measuring the mass or the size or the weight of the lizards. I think Rachel. Okay, take a look at the last one. Number 10 says, Patrick puts 3 identical plants in the same amount of soil in 4 inch pots. He puts the pots in direct sunlight. He gives one plant half a cup of water a day, one plant a fourth a cup of water, one plant 1/8 a cup of water. At the end of the week, he measures to see which one grew the tallest. What is he changing on purpose? The amount of, excellent, the amount of water. And what is he measuring? You're right, it is the height of the plant. Go ahead and fill those in at this time. So now what we are going to do is evidence dive 2, 3, and 4 are on your own. What you need to do right now, you are working silent and solo. Do your best to fill all 3 of these pages in. At the end, you'll put a thumbs up, and that thumb up will let me know that you are ready to check your answers. Go.